Hello, chicos. Today we're going to do lesson 2. It's a review of negative exponents, product and power theorems for exponents, and circle relationships. So let's start with negative exponents. Remember that an expression with an exponent has a base and the exponent, which is the 3 in this case. And it's telling us how many times the base is going to be multiplied. So it's 2 times 2 times 2, which in this case is 8. Now, if I have a negative exponent, what that does is that it gives us the reciprocal. So it's going to be, instead of 2, it's going to be 1/2, and then I still have the 3. So now I have to do 1/2 times 1/2 times 1/2, which is going to be 1/8. So in general, I can say that if I have x to the negative n, that's going to be the reciprocal of x to the n power, in this case positive. It's like the negative exponent is just like a token that we use to get the reciprocal. And once we have the reciprocal, which means just turning around what is on the top to the bottom, numerator with denominator, then we can get the positive exponent and then just calculate it as usual. So let's look at these examples. As you can see, they all have base 3 or negative 3. And they have different exponents. So let's see what's happening. First thing I'm always going to do is simplify or get rid of or use the token of the negative exponent. So if the 3 is in the denominator, it's going to send it to the numerator. So now I'm just going to put 3 to the positive 2. Why positive 2? Because the negative is gone. We don't need it anymore. So 3 to the second power is 9. Let's see the next one. In this case, we have 3 to the negative 3 power. And again, I'm going to use a negative first. So I have to write the reciprocal of 3, which is 1/3. But now I have that 3 positive here. And if I multiply 3 times 3 is 9, times 3 is 27. So my answer is going to be 1/27. The next one has a negative in front of the number and also a negative in the exponent. And again, I'm going to start with that one. So I'm going to put the reciprocal of 3, which is negative 1/3, with the 2 here. Positive because we already used the negative. Now notice, the negative stays there. The negative sign, this one, stays there until the end. We're not going to do anything yet. And notice also how we don't have a parenthesis. If anything, we have this fractional line, so we're going to do this first. Okay? Only the 3 is to the second power. So 3 to the second power is 9. So we have 1/9 with the negative 1/9. Okay, let's look at the next one. Notice that the difference between these two, between this exercise and this exercise, is the parentheses. You have to be very careful with that. And so in this case, we have negative 3 to the negative 2 power. And what we're going to do is we're going to use again the negative first. So the reciprocal of negative 3 in parentheses is negative 3 on the bottom. So 1/3 with the negative there in the parentheses. Now notice that that's going to be different because in that case, I'm multiplying negative 3 times negative 3. I'm doing that first. So it's going to be positive 1/9 because negative times negative is positive. Notice the difference between these two. The signs. One is positive and the other one negative because of the parentheses. Finally, we have several negatives here. But again, we're going to start with the one in the exponent. So we're going to keep this negative until the end. And then we're going to write the reciprocal of negative 3 and then exponent 3. And if I simplify that, I'm going to bring down this negative. And that's going to be negative 3 times negative 3 times negative 3, which is negative 27. And then I have to multiply negative times negative, positive 127. So notice how important it is to have those parentheses there because they totally change what the exercise or the answer will look like. All right, now we go with the product theorem. And what is reminding us is that if I have a base with an exponent times another expression with the same base and an exponent, what I do is I keep the base, but I add the exponents. Okay, very, very simple. If I have x to the 5th power times x to the 7th power, I don't multiply 5 times 7, but what I do is I keep the x and I add 7 plus 5, 12. Okay, now why? The reason is because remember that this is telling us how many x's are we multiplying. So here I'm saying I'm multiplying 5, and here I'm saying I'm multiplying 7. And so if I count how many I'm multiplying at the end, I'm going to have 12, and that's why. 12 x's. Okay, let's do the examples. In example 2.2, we have some x's and some y's. So I'm going to work with the x's first. Notice how all of them are multiplying. And what I have to do is just add 2 minus 5 plus 5 plus 0. That's going to be x to the 2nd power. And then we do the y's. We have a y1. Remember, there's a 1 there. 1 minus 4 minus 3. And that's it. Pretty simple. We just add because they're multiplying. In 2.3, we have the multiplication on the top. Then we also have a multiplication on the bottom. And then the fractional line is going to divide. So we have to be very careful. So let's do it. So we're going to start with the y's. So we have 1 minus 3 is negative 2. And negative 2 plus 5 is 3. And then x, we have 4 minus 10 is negative 6. Then we go and do the one on the bottom. And again, we do the y's first. Negative 6 plus 10 is 4. And the x is negative 3 plus 2 is negative 1. Now remember that just as if two numbers are multiplying, we add the exponents, we do the opposite if they are dividing. If they are dividing, we subtract, okay? And so in this case, it's going to be y3 minus 4 and x is negative 6 minus 1. So my answer will be y to the negative 1 power and x to the negative 5th power. Now why? Because remember, negative times negative is positive. So negative 6 plus 1 equals negative 5. Okay? Another way to see that, you can also see it, think about it, that you are changing the sign to pass it to the top. So it's going to be 3 minus 4. And then you change the sign of negative 1 and it comes here as positive 1. So either way, you can think about it by changing the sign, or you can think about it that you are subtracting. Either way is the same, the power theorem. And so what we have to remember is that if I have an exponent to another exponent, in this case we do multiply. So it's x to the mn. So for example, let's do one here. If I have x to the 5th power to the 3rd power, I multiply and I have x to the 15th power. So let's look at example 2.4. I have x to the 1 power here. I have this one here. So I have to rewrite that one. So let's put it x to the negative 6 because negative 3 times 2 is negative 6. Then we have y1 and then we have to do this one. But negative 3 also has to multiply here that there's a 1. So let's put x is 1 times negative 3, which is negative 3. And y is negative 2 times negative 3, which is positive 6. Same thing on the bottom. I have to multiply, so y 6, y negative 3, and x 2 times 3 is 6. Notice that now we go back to the previous examples where we have to multiply and divide. So I'm going to do, let's go here. We're going to do all the x's on the top, which would be 1 minus 6 minus 3, which would be negative 8. And then the y's, which are 1 plus 6, 7. We do the same on the bottom. 6 minus 3 is 3. And then x6 stays the same. Finally, we're going to subtract negative 8 minus 6. And for the y's, we have 7 minus 3. The final answer will be negative 14, and the y is 4. Finally, the last topic on this lesson is circle relationships. Now, let's start by remembering that we have a center, and that center is like our point of reference. And all of these points here in the circumference are at the same distance from the center. And that distance we call a radius. And two radius together are the diameter. Now, we also have to remember that there are formulas that we can use to find both the circumference, which again is that purple area around the circle. And so the circumference equals diameter times pi. And remember that we find that by multiplying the diameter 3 times and a little bit more, 3.14. We also can do it in terms of the r, 2r pi. And then finally, the area, which is radius squared pi. So in this example 2.5, we're going to use these formulas and this relationship to find what they're asking. So in this example 2.5, they say the area of a circle is 12.2 square meters. What is the approximate circumference? So this is a two-step problem. We're first gonna have to find the radius, and for that we're gonna use the formula area equals radius squared pi. We're going to change the area for 12.2, and then we're gonna pass the pi to divide. Remember that pi is 3.14, so when I divide that equals 3.8. And then to find what that is, I have to find the square root on both sides. And that is going to be 1.97. That's the approximate radius. Now with the radius, I'm going to use the circumference formula to find the circumference, which is 2 times 1.97 times 3.14. And the answer for that circumference is 12.37. Okay, chicos, that's lesson 2. I hope you guys learn a lot. And if you have any questions, please remember to write it in the comments and I'll do more videos to help you. All right, see you in the next video.